Welcome to your Business Calculus Lesson 4.3, Part 2 on second and higher order derivatives. Okay, since the derivative is a function, we can find the derivative of the derivative. So, for example, if f of x equals x cubed, the derivative is f prime of x equals 3x squared. And then we can take the derivative of 3x squared, just apply the power rule one more time, and you'll get 6x to the first, or just 6x. So just like f prime of x shows how f of x increases or decreases, f double prime of x, the second derivative, shows how f prime of x increases or decreases. All right, so we want to find the second derivative of y with respect to x of 2x cubed minus 3y cubed equals 7. Now, this is one of those cases where we can't solve this for y and come up with a function. We'd have two separate functions. So we'd have one when we took the square root for the positive square root, one for the negative square root. We're not going to mess with all that. We're just going to do implicit differentiation to get our first derivative. All right, so when we do implicit differentiation, we're going to get 6x squared minus 6y times y prime. That's another way of writing the derivative of y with respect to x, the dy dx. You can just write it as y prime. And the derivative with respect to x of 7 is 0. So now we want to solve for y prime. So we're going to subtract the 6x squared over and then divide by negative 6y. And we'll get that the first derivative is negative 6x squared divided by negative 6y. So now to take the second derivative, we're going to take the derivative of the simplified form of negative 6x squared over negative 6y. So we reduce that to x squared divided by y. Now we'll do the second derivative. All right, we do have a quotient. So we're going to have low d high, okay? So y times 2x minus high, x squared, d low, since it's just plain old y, and the derivative with respect to y is 1, times the derivative with respect to x, y prime. And then we square whatever's down below, so we have y squared using the quotient rule. And so we can break this up to be 2x, y times 2x over y squared, which will reduce to 2x over y. And we can have minus x squared over y squared times the first derivative. At this point, this is really cool. We can substitute y prime back into the equation. We can take this x squared over y and plug that in. How cool is that? And so we're going to get 2x over y minus x to the fourth over y cubed. Okay, the second derivative in concavity. Just like f prime of x shows how x increases or decreases, f double prime of x shows how f prime increases or decreases. When f double prime is positive, the f prime increases. The graph is concave up. It's smiling at us. So one thing that we can do is make like a little sign chart down here, and we can look at where we can chart where the first derivative is negative, positive, and equal to 0, and then the same thing for the second derivative. So here we go. Down here, inflection points. So a point where the second derivative changes sign is called an inflection point. And there is a concavity change from up to down or from down to up. So it'll kind of be like a wiggle in it. So here's concave up, here's concave down. So if it switches, it's going to wiggle and start having the opposite concavity. At the inflection point, either f double prime of x is 0 or f double prime is not defined. Okay, so here's an example. We've got y equals x cubed minus 6x squared plus 12x minus 5. So our first derivative, just using the power rule on each term, is 3x squared minus 12x plus 12. The second derivative is going to be, okay, let's apply the power rule again. So 6x minus 12, and then our constant has a derivative of 0. All right, so let's consider where 6x minus 12 is negative and positive. It's going to, if we set it equal to 0, we're going to get x equals 2. If you look, it's going to be negative up to x equals 2 and positive after that. And so f of x is concave downward up to x equals 2, and f of x is concave upward from x equals 2 on. So here's a picture with our inflection point at 2, and here it's concave down, okay, and here it's concave up. All right, let's look at this one. We've got y equals 5x cubed plus 2x squared minus 3x. Our first derivative would then be 15x squared plus 4x minus 3. Our second derivative is going to be 30x to the first, so just 30x plus 4, and then our constant has a derivative of 0. So 30x plus 4 is going to be negative up to x equals negative 4 over 30 or negative 2 over 15, and positive from that point on. And so f of x is concave down up to x equals negative 2 over 15. So here we have a picture of it being concave down until x equals negative 2 over 15. And then it's going to be concave up for every x value following that. And our inflection point is at negative 2/15. We don't have to stop with the second derivative. We can find the derivative of the derivative of the derivative of the, you get it. It keeps on going. And for the following, you could calculate all the derivatives, and we can just keep going up until we get to the nth derivative, where n is the degree of the original function. All right, guys, thank you for watching this. Go ahead and print out your problem set and attempt any problem that you can, and we will continue to work together during class. Thank you for watching the video, and I hope you have a great day.